right, everyone. It's 2:20, so we'll get started. This session is going to be 30 minutes. It's going to be on accelerating container builds. So building containers today mostly involves Docker files. There's a lot of, has anyone heard of the Open Container Initiative? So Open Container Initiative is a standardization of the runtime and the format for a container. So if you build a Rocket container or a Docker container or a ClearCase container, all that adheres to the same format. But mostly containers are actually built the same way, and that's using Docker files. Unless you're in a system like OpenShift where we have things like source to image, but that's actually doing Docker file builds behind the scenes. There's a few other things that are going on in parallel. So there's an Ansible project called Ansible Container Service, which is for people who want to use Ansible to build containers. And there's another project from Red Hat called Buildo, which is actually with a Boston accent, but it's to do similar things to what the Docker file is doing, but in a lighter weight fashion. But since most of the use cases are around Docker files, I'll spend most of my time going through some best practices here. We only have 30 minutes, so I'm going to apply the 80-20 rule, the low-hanging fruit, like where we can get the most bang for our buck, but this is by no means like an exhaustive list of best practices. So anybody know how large this is a Docker file, by the way. It's basically a list of commands to run to build out your system. I did not purposely make this a terrible Docker file, but this is what most of the Docker files look like on Docker Hub or that I've seen people build. But it basically does, it pulled down a RHEL 7 base image, which is about 200 megs. And then it installs OpenJDK on it, which is about another 120 megs. And then layers Tomcat on top of that. It doesn't even put in a Tomcat app, just the war itself, or just the Tomcat zip itself. So about 330 megs of data. How large do you think this image is? Anyone have a guess? 1.23 gigs. 1.23 gigs. So about 4x what we would be expecting based around the number of bits that were pulled down. Anyone have any other things that they spot wrong in here? What's that?
Is a lot of that coming from the YUM update?
Yes. A lot of it is coming from the YUM update. So you probably noticed also I have a version of RHEL here, and I'm just using the latest. This presents a couple problems because one, now my containers, every time I do a subsequent build, if the cache doesn't break, I don't really know which version of the OS I'm using. So it's really an anti-pattern to use latest as your versioning. You want to tag to a specific version. So in this case, I've tagged to RHEL 7.3. This is a little better, but still not great. Does anyone know why? Security updates. The day 7.3 is released is a lot different than 90 days after 7.3 release. There's a lot of differences there. We're going to be maintaining an image there. Red Hat specifically actually maintains like micro releases of these, so I can tag it with TAC89. That actually does mean something for Red Hat. When I put that, that's actually the latest version that you can look into our container, Red Hat container catalog. It'll give you that information. Tarek here in the front row has actually written a pretty good blog about this, but Docker tags by themselves are actually meaningless, essentially, because I can have something called -1.0, -2.0, or -latest, and then I can rebuild and push a new image with that same tag. So there's really no consistency between builds if you're just going by tag. But you can pull by hash. There's another way to guarantee consistency. So I can do this, and that's really ugly, right? No one would want to see that. And I also, not only is that really ugly, but I have no idea what version of RHEL that's based off of. No idea. So one thing I can do differently here, well, I'll come back to this later because actually we'll build onto this as well. So the order matters. So the YUM update, that's the main culprit of the size for a Docker file, but there's other culprits as well. So does anyone know what this statement does? YUM clean all?
It's the repo cache.
Yes, correct. Do you know what it's doing in this container? Almost nothing. Almost nothing. It's like when they ask you a question in math, you usually guess 0, right? So it's doing almost nothing. The reason why it is removing the repo cache, but the way Docker images work is they layer on top of each other. So if I start shipping around this container, not only did it remove the repo cache from the container image, but it's actually still there and I'm still shipping it around. So if I run this container on 10 different machines, I'm shipping around the yum container cache 10 different times, but if I actually go into that container, I won't see it. Does that make sense? You can do something called squashing the container, which builds all the layers together, like smashes them into one, but it's extra steps, and I haven't seen too many people doing it. The reason why it uses this kind of copy on write technology is because this is what makes the build so fast, and this is what makes the containers so fast. But you have to be aware that if I'm cleaning something up, it really needs to be done in the same line. So if I actually just concatenate that all with chaining the statements right here, I've actually cut my image down by 700 megs. So something that was really small that I might not have realized actually just removed 700 megs from my container. The difference would have been greater if I was using an earlier version of RHEL. So if this wasn't RHEL latest, say I was using RHEL 7.1 here, it would have been even greater. Does anyone know why? Security, more updates, basically. So the yum update would have even been bigger. The metadata to pull down that information would have even been even more. So a simple chaining can go a long way, and it's really low-hanging fruit that you should be aware of when you remove your when you clean up inside your container. So what happens here if I do a build and I download the latest version of RHEL, and then next week I do a build on the same machine?
Did you update your machine with new content?
Yes, there's been a new instance of RHEL 7 that's been pushed into the Red Hat registry. But I'm on my laptop. I've done a new build with this Docker file.
Get the latest unzipped version.
If I'm on the same machine, I'll actually get nothing because this will be all cached.
If you have a different machine, then get the new.
Yeah, and if you have a different machine, you'll repull. So one of the things we can do here, and this is the same thing here too, like the way the Docker cache works, which is also really important, is it'll basically cache everything all down. Each one of these is their own. Each of these lines is their own image. It gets stacked onto one another until I break something. So if I change this line here, this copy line, it'll cache everything to copy, and then it'll rebuild from there. So unless I went all the way back and changed this line, it'll keep caching it on my local machine. Also, I don't quite know if I did break the cache, unzip. Not a lot of changes of unzip happening, but for other libraries, it's really important to pin them. So I want to put my specific version here. This is the equivalent of doing latest up here with RHEL.
Is the trick to pinning them just simply putting the version?
Yeah, just putting the version like TAC, 1.3 or whatever.
Get the current version of that software. Like so, if you're running RHEL latest and you want the unzip, you want to pin it to a version.
Mm-hmm.
Get the unzip version.
You can do yum search if you want. You can also go, one thing that I use a lot, and which is pretty new, is in the Red Hat container catalog, which is just access.redhat.com/containers. We've added all sorts of metadata about the containers. You can actually go in and look at any container now and look at the Docker files there. So usually that's helpful for referencing. But if you have a regular like RHEL host, I just do a yum search to figure out which versions are updated. Also, anyone know what repos I'm using here? What Red Hat repositories I'm using to pull these RPMs from?
The ones in the base image.
Nope, good guess though.
The ones that are attached to your host.
Yes, the ones that are attached to my host. So the way Docker works for a Red Hat image when it does a build is it's actually going to, unless you explicitly say otherwise, it's going to use the Red Hat repo managers of that host. So I can get around this, and I can, usually as a best practice, I tell people to manually put in the repositories that they need in the Docker file, and I can show you an example of that. But the reason is because if I ship this Docker file around between other instances and build on other servers, I might have different results because those hosts might not be subscribed to get to the yum updates that I need. So one thing that you can do to get rid of this caching issue is to separate it out into base images. So in this case, I have a base image that my organization's using, to enable certain repositories, to do a yum update, and to pull down the latest instance of rel. When I want to update this image, when I want to update rel, I just rebuild this image. But for my app, I just point, instead of pointing to Red Hat, I point to my base image, which points to Red Hat. So now I know that I'm always using the latest, approved for my organization. When the organization needs to do updates, it can just rebuild this here. And then when I do a rebuild, I can, if I want to, I can break the cache and pull down from here. But now I've kind of abstracted this away, and another team can kind of maintain this, because odds are the same person that's building a Tomcat app is not going to be the same person that's doing like a yum update. I said judgment call here because you might tie this to specific versions. You might use a hash in here, because this TAC89 it does mean something to Red Hat, but it might not mean something if you're getting your repositories from somewhere else, your base image from somewhere else. So they told me I couldn't talk about products, but I do have one slide on OpenShift because this is really important, because this is all handled for you inside OpenShift. So using that layered concept, when you build an application on OpenShift, it actually uses what's called an image stream. And these image streams are different pieces. So I might have a rel layer here. I might have my middleware. I might have another piece that's my organization's lockdown, STIGs and so forth on top of that. It's doing two things here. One is it's taking care of the arbitrary tags issue. So the image stream is actually polling the registry and getting the SHA-256 hash. So when I spin up one instance or 1,000 instances of this image, they're all generated from the same hash. It doesn't matter if there's been an update to that image in the back end, it's pulling the SHA-256 hash. If I want to have different life cycles, so for instance, when there's a rel update, I might want to do some manual testing, but if there's a Tomcat update, I might want to automate that. I can set up different type of redeploys based around each layer in the image stream. So that's just an important concept, and it'll be the only OpenShift thing I really mention. But this is really important because when you go back to here, maintaining this and kind of do it on your own can get pretty ugly. How do I get rid of this file? You have an idea on this one? So I've copied in, basically all I've done is I've copied in the Apache Tomcat zip file into my container. And then later I'm unzipping it, and then I'm removing the file from the container. Anyone have an idea? So I really can't. The only way I could really do this is to, one, curl it, pull it down from somewhere off the internet, or better case, since I have the files locally, I just unzip it before I pull it into the container. So I just unzip it in my directory and pull it in that way. And then these statements actually aren't doing anything because, yeah, they're removing it from the image, but they're still in what gets shipped around. So they're not actually saving me any space or really removing like the burden of shipping around large containers. So copy versus add. I won't get into the too nitty-gritty, but they more or less do similar things, but add is very old. I'll save you all the hoopla. Use copy if you're creating a file over add. But one thing I will mention too is when I talked about the cache only breaks if you change one of the layers in the Docker file. But one thing that's actually cool behind the scenes is it's doing checksums of all the files. So if I was actually copying in like XML configuration into my container and I change that XML file, I don't need to manually go bust that cache. It's going to be invalidated by the fact that the checksum's now changed. So in this case, I just unzip it outside the container. So expose is an interesting one. Does anyone know what happened if I just spun this container up and tried to connect to port 8443 on my laptop inside the container? It'll work. Do you know what would happen if I move this into Kubernetes? It won't work because this expose is really just metadata. It's not changing how your container works. This isn't a firewall rule. I can bind this to my local host, and then I can listen to any port the container is listening on. But inside Kubernetes, Kubernetes actually looks for that expose port to really generate and hook into like the software-defined network and so forth. So it is important that no matter what ports that you're using, that you explicitly mention them inside your Docker file. Anyone know what user this image runs as? Well, it runs as root unless I ran a user statement inside of this base image, which we don't like. We don't like running as root for lots of reasons. You might have a scenario where you want to run some software that has to run as root. There's ways we can mitigate that with a security profile that limits what root can actually do. But if we can't help it, we don't want to run as root. We want to create a user inside the container and then switch to that user, which is a matter of just typing the word user and then the user's ID, the UID. And then finally, you can run, to start your container, you can run a command or a script using a command statement or an entry point file. The entry point file is how most of the official images work. Like if you look for Postgres or Redis or something on Docker Hub, it actually uses an entry point file. So that's basically a bash script. If you do any initialization, you'll end up using an entry point file. The cool thing about commands, though, is that if you type Docker run and then your image name, you can actually override command by just typing anything after that. So if I just type Docker run my image, then bash, I'm now bashed into the container. So a little bit of recap. This isn't all my content, but I just wanted to stop recap here because I just threw a lot of different things at you. So we want to version our OS in all our dependencies because we want to know exactly what we're running. We want to look at Docker tags and use hashes where we can, where it makes sense. We're not going to use hashes everywhere because they're hard to read, and I don't have any way of turning that back into figuring out which particular version that was. But I do want to use them where I can. If you're inside OpenShift, you use image streams, which handle all that for you. The container, the order really matters for the container. So we can't remove anything from a previous image. Everything just builds on top of each other. And then fewer cache invalidations. So generally, we want to cache as much as we can just because subsequent builds will be faster. But we have to be careful that any changes that have been made, if it's being cached, we're just getting the older version. Also, use copy where we can, expose all our ports, and avoid running as root. One other thing I'll mention, too, about running as root. So we want to use as a non-privileged user, and we want to switch, we'll type user and then that the UID. But we also want to avoid switching back and forth constantly. So normally it would make sense like towards the end of your Docker file to switch the user. And if you actually look on the official images for a lot of containers like Redis or Postgres, they actually use something called gosu, which will switch the user, de-escalate the privileges within inside the entry point. So minimal images, it's a really popular topic. So, and this is just an order of some of the popular Linux distros that have been out here. A couple years ago, these were all 600 megs. We've slimmed them all down by removing a lot of stuff that isn't necessarily needed inside a container. So a rel-based image is 192. We actually just came out with something called rel atomic, which is 75 megs as a base image. It'd be used for things that run static binaries like Go, Alpine, something that's been popular on Docker Hub. I wouldn't really recommend it because it doesn't use glibc. So the way it can interact with a kernel can be kind of funky. Does anyone know what would happen if or how much space it would take if I built a 200 meg container with, let's say, 10 different apps, or each 100 meg each, and kind of ship those around? Sorry for all the math, but I'll give you the shortcut. You basically only ship this once. So every time I ship a new app, this space kind of fades away. So I generally recommend something you want to send out reasonable defaults, essentially. Because going back into that ordering of everything, if I have, like for instance of Tomcat, if I have a approved official organization image with Tomcat in it and rel and the tools I need, and say that adds up to like 300 meg, I'm only going to ship that around once, and it doesn't matter if I run 100 containers on top of it. I'll only, for each of those 100 containers, only ship those differences. So it's not like you're multiplying that 300 meg. So it's really about finding, you want to build minimal containers, but you also want to use reasonable defaults. If you actually end up with a lot of one-offs, you can actually end up taking up more space. So, and also some of these ones that are super slim don't have any tools inside of them. So if you want to use curl or do something else inside the container, you end up having to do yum installs anyway. And a lot of times they become just as big. So the rel atomic-based image is actually something that most people aren't familiar with. But the reason why rel image is still 192, and the rel-based 8 images when they come out will actually be smaller because they've rewritten a lot of things. But yum actually has a dependency on Python. And Python is actually the main culprit for why it's even 192 megs. So we've rewritten yum, something called microdnf, rewritten it in C. And then taken out Python and systemd, and then some of the SUID libraries. This works basically exactly the same way yum works. So if you do a yum update, you just do basically anywhere you would see yum, you just replace it with like find all and replace for microdnf. If you need Python or something that's compiled, it's probably not as helpful. But if you run Go or like a C app inside a container, like this can be pretty helpful. So systemd. Systemd has kind of been a controversial topic inside containers the last few years because when you run something in a container, everything runs as PID1 in the container. And that's really important because that's on a Linux system, PID1 is what gets initialized. So on a rel host, that's systemd. Inside a container, that could be whatever your app is, right? And systemd does a lot of things for you. And in most cases, you won't need it, and you won't want it in your container. But there are some cases where you really do want it because it handles a lot of cleanup for you and does things that you probably wouldn't realize. So one thing is it catches zombie processes. So if you have something like Apache, which spawns off processes for all the requests that come in, and those start to go rogue, you actually need systemd to clean that unless your container actually knows how to handle the Linux term signal sigchild, which I haven't seen anybody in their code connecting sigchild. So that's really important. Chuck's now taking pictures of it. You also, you really don't want to build your own init system. SQL Server, which just came out for Linux, so shoot.
Sorry, quick question. If you have a zombie process in a container and then you kill that container, will the zombie process still stick around?
No, it'll be gone.
Okay.
Yeah, so you can kill the whole container, but if you have like a long-lived container, containers are meant to be ephemeral, but like in my experience, they actually move around even less than VMs because like if you use VMware, like can start vMotioning things between machines, but containers just run until they die. They normally don't get migrated. That's just not how they work. Eventually, if they die or they just respin up somewhere else. So systemd does help you. SQL Server, which just released from Microsoft, which was actually the fastest version of SQL Server ever for 1 terabyte and under on RHEL. So we have customers that run that with inside OpenShift and support it through Red Hat and Microsoft. It's kind of a joint support thing right now. That uses systemd. They designed it to use systemd because it handles some of that cleanup and so forth for you. So systemd also, and the reason why I have a whole slide on this is because systemd is actually hard to run in a container because it has a lot of things that were built without containers in mind. So if you want to go see what all those things are, there's a very long list on how to actually make it work by yourself in this blog. And we'll put all these slides up so they're public. But we actually have a new base image right now, which is like the easy button for systemd. So all I have to do is type in, use this rel7-init container, and then systemd already works out of the box without being a privileged container. So I think this is my second to last slide, just gives me only 4 minutes yet left. So we also have something called source to image, which works in OpenShift, but it's actually not an Open specific project. You can actually run source to image on your laptop, and what it does is you basically give us your Git repository. We build all the code for you. All that's great, but a lot of people don't want things like Maven running in production, right? Because the way the build to image works is I'm actually building everything and then checking that in as an image into my repository, and then I run what's built. But I don't really want to. I don't want all that Maven tooling. I don't want all those jars that's adding size. I also just don't want something running in production that could potentially be modified, like from a security aspect, right? And DockerCon, they actually released something called multi-stage builds, which is with inside one Docker file, I can build a bunch of stuff and then just copy over, like for instance, a WAR file, and then build a runtime that's separately with just that WAR file, and it doesn't have anything other than the WAR file that was copied over. With inside our source to image capabilities, we've actually had this since OpenShift 3.0 for a couple of years now. And this is just a diagram of how it works. So this would be like in your build config inside Kubernetes. But you have a container that does the build. Instead of that being also the same container that you run in prod, I just copy over my WAR file into another runtime. These have trade-offs if you're deciding between the two. I think the main benefit to the multi-stage build, it's all in one Docker file. It's a little easier to manage. There's some really big benefits to using the source to image, though, which I think the biggest thing is that I now have enabled separate teams to manage these things. So I can have one team that maintains my runtime build and another team that maintains the build time, which is really important because I'm probably not going to have, unless developers run the entire show, which I usually don't see. I have seen it a couple times, but usually you don't see it. These are typically different different organizations here. So that's one benefit as well. So this is kind of an all-in-one Docker file way to do it, and this is through the source to image build config way to do it. But the idea is now I've created an even smaller container, and I've removed some of the development tooling that I need to build my libraries. So we've got 1 minute left, which is perfect. Keep our images portable. So we don't want anything that's specific to any of our environments. We want to use environment variables and configurations that can be mounted to the containers. If you're actually inside Kubernetes, you can mount like config maps, which is basically just files that you mount inside of a container that might vary between environments. And then service discovery. So I'm not hard coding IP addresses. I'm looking for a database with a generic name. And through service discovery, I can find that database, depending on which environment I'm in. Which is good, because now we have 30 seconds left. So we can just look at a picture of my daughter. So.